Hi everyone. In this video, we'll go through topics related to singular and non-singular matrices and inverse of a matrix.
What is the inverse of square matrix? It is a matrix. It's a matrix. If you multiply that particular matrix with the matrix, you will get identity matrix. That is, if you take, say, matrix A and say there is another matrix which is called as A inverse. That this is another matrix, this is matrix A. When you multiply these matrices, you will get identity matrix as the result. So this matrix becomes the inverse matrix. Any matrix when multiplied with another matrix, if it gives you identity matrix, then this matrix becomes the inverse of this matrix. So identity matrix is nothing but matrix with ones in the diagonal and all other zeros. So this is an identity matrix. So this is an identity matrix for 3 by 3. This is for 2 by 2. So you have two matrices. When you multiply two matrices, if you get the result as identity matrix, then one matrix is called as the inverse of the other. There is a formula to find the inverse. This is the formula. Inverse of matrix A is adjoint of A by determinant. Adjoint of A by determinant gives the inverse of a matrix. Also, we need to remember a few things. A into A inverse is I. A inverse into A is also I. Let's take an example. Find the inverse of this particular matrix. Now let's call this matrix as A, right? Let's call this as A. Now, what is the formula for inverse? It is A inverse is equal to adjoint of matrix A by determinant. So let's find the determinant. Determinant is cross multiply. So 2 into 2 is 4 minus of minus 3. So you're going to get minus 1. This is determinant. Now we'll have to find adjoint. Right? Once we find adjoint, we'll divide them and you'll get inverse of matrix A. So adjoint A is finding the cofactors, right? Now for 2 by 2 matrix, there is a shortcut. So interchange the elements. Interchange the elements, 2 and minus 2. So you get minus 2 and 2. Now you change the signs. So minus 1 will become plus 1, 3 will become minus 3. So this is adjoint. What is A inverse? A inverse is adjoint of A. That is this matrix minus 2, minus 3, 1, 2 by determinant A. By determinant A. That is by minus 1. We can also write it as 1 by minus 1 into this particular matrix. You can write it like this. This is nothing but A inverse is equal to, it's going to be minus into minus 2 minus 1 plus 3 minus 1 into 2 minus 2. So this is the A inverse. Let's take another example where we have to find the inverse of 3 by 3 matrix, right? So to find the inverse, first we'll write down A inverse is nothing but adjoint of A by determinant of A. So let's find the determinant. First, determinant is, we'll choose a row which has the 0 to make it easier. So we'll choose the third row. So determinant is minus 3 into, ignore this row and this column. So it's going to be 4 plus 3. We'll have to remember the sign. Sign is minus. Then we'll go to the next element, which is 1 plus 1, because you have plus here, plus 1 into 8 minus 1. 8 minus 1. So we'll get 7, 21 plus 21 plus 7. So you get 28 as the determinant. Now we'll find adjoint. Adjoint of matrix A. Now it's a 3 by 3. So we will have to find all the minors. Right? Let's find all the minors. We'll have to go element by element. Let's take first element. First of all, signs are very important, right? For cofactors. So you put the signs. First one is plus, minus, plus. Then you have minus, plus, minus, plus, minus, plus. Now let's find the cofactors, right? So first element 2, 4, 1, 2, 3. 4, 2, minus 3, 1. And for the second one, minus 1, you have minus 1, 2, minus 1, 2, 0, 1. Third one, for 3, this one, minus 1, 4, 0, minus 3. So let's find the cofactor for fourth element now. This is the fourth element. So what is the cofactor? Let's ignore this row and column. Minus 1, we get minus 1, 3, minus 3 and 1. Similarly for fifth element will be 2, 3, 0, 1. 2, 3, 0, 1. Sixth element would be 2 minus 1, 2 minus 1, 0 and minus 3. We'll go to the seventh element, 0. So it's going to be minus 1, 3, 4, 2. Minus 1, 3, 4, 2. The next one is minus 3, right? Cofactor for this would be, ignore this and this. So you'll get 2, 3, minus 1, 2. 2, 3, minus 1, 2. And the last one for 1 It's going to be 2 minus 1, 2 minus 1, minus 1 and 4. And let's not forget to put this transpose here. This T indicates that you have to find transpose later. Now let's calculate this. So if you calculate, you're going to get 4 minus 6, 10. You're going to get 10 here, minus 1 and minus 1. So it's going to be plus 1. 3, minus 1 to 1, minus 1 and plus 9. So it's going to be 8, minus 8. 2, then 2 3s are 6, minus 6, minus of minus, plus 6, cross multiply, minus 1 into 2, minus 2, minus 12, minus 14. 2 into 2, 4, 2 into 2, 4, 4 minus of minus, 4 plus 3, and here minus, so minus 7. 2 into 4, 8, 8 plus 1, 8 plus 1, which is 9. So now we have the cofactors. Let's find the transpose. Transpose would be 10, 1, 3. Write it as column. Minus 8, 2, 6. Write it as columns. Minus 8, 2, 6. Minus 14, minus 7, 9. Put it as column. Minus 14, minus 7, 9. So we have taken the transpose. Now we have the adjoint of A. Now we'll do the final step to find A inverse. A inverse is 1 by A determinant into adjoint of A. Right? 1 by determinant. What was determinant that we got? 28. 1 by 28 into this particular matrix. So we'll have to multiply now to get A inverse. So A inverse is 10 by 28. 10 by 28 minus 8 by 28 minus 14 by 28, 1 by 28, 2 by 28, minus 7 by 28, 3 by 28, 6 by 28, 9 by 28. Now we'll simplify this, right? So we'll get 10 by 28 is 5 by 14 minus 2 by 7, 2 by 4, 1 by 28, 1 by 14, 1 by 4. So if we simplify this further, that is, we can simplify these fractions and we'll get this as the final matrix. So this is the inverse. Let's take another example where if matrix A is given, we'll have to show that A square minus 5A plus 7I is equal to O. This is the zero matrix or null matrix and I is identity matrix or unit matrix. So you'll have to prove this and then find A inverse, right? So there are two problems within this problem. So first is we'll have to find out this particular expression. We'll have to prove that A square minus 5A plus 7I is equal to O. So let's substitute. A is equal to 3, 1, minus 1, 2. A square, we'll put this 2 times. A square minus 5 into matrix A plus 7 into identity matrix. So it's going to be a unit matrix. And you have to prove that it is zero matrix or null matrix. So we'll take LHS first. LHS is this portion and this is RHS. So we'll take this LHS and after simplifying this, you have to get a null matrix. So let's multiply this. So it's going to be 3 3s are, it's going to be 9 minus 1. 3 1s are 3, 1 into 2 plus 2. Let's come to the second row. Minus 1 into 3 is minus 3 plus minus 2. Minus 1 into 1 is minus 1 plus 4 minus 15, 5, minus 5, 10. So multiplying with 5. Now you will multiply with 7, 7, 0, 0, 7. So once we simplify this LHS, we should get zero matrix. So let's simplify. 8, 5, minus 5, 3, minus. You can do all 3 matrices in one shot, or you can first take 2 matrices, subtract, and then add it with this particular matrix. So 8 minus 15 is minus 7. Minus 7 plus 7 is 0. 5 minus 5 is 0. 0 plus 0 is 0. Minus 5 plus 5, 0. 0 and 0, 0. 3 minus 10 is minus 7. Minus 7 plus 7 is 0. So this is equal to RHS. So we've got the zero matrix. So we have proved the first part of the problem. Now second part of the problem is to get the A inverse, right? We'll have to find A inverse. So we have a property or a formula which says that A into A inverse is equal to I. A into A inverse is equal to I. So we'll take this expression A square minus 5A plus 7I. A square minus 5A plus 7I is equal to 0. Using this expression, we'll have to find A inverse. Using this. So what we will do, we'll multiply both the sides with A inverse. We'll multiply so that we get A inverse in this expression and we can find out this particular matrix. So we'll multiply on both sides with A inverse. So when you multiply, you'll get A inverse into A square minus 5 into A inverse plus 7 into A inverse into I is equal to O into A inverse. So we can write A square as A into A, and then we have A inverse. A inverse into A is nothing but I, identity. So we can substitute A inverse into A is I into another A into A. Then A into A inverse is I. So 5I plus 7 A inverse into I. So there is a property that A inverse into identity is A inverse itself. This is like telling 5 into 1 is 5. So this I is something like 1. So when you multiply I with any matrix, you will get matrix itself as the result. So I is like 1 here. So 5 into 1 is 5. So similarly, A inverse into I is A inverse itself is equal to, similarly, O into A inverse. O is like a 0 in the number system. So 0 into anything is 0 itself. So you'll get O here, right? Another thing, right? Again, I into A is A itself, right? So we'll have to write this as A minus 5I plus 7A inverse is equal to 0. So we'll have to figure out this A inverse. So to figure out A inverse, let's shift all of this to the other side. So we'll get 7 into A inverse is equal to O minus A plus 5 into I. Then A inverse is, bring 7 this side. So we'll get 1 by 7 into O minus this part. O minus anything is this itself, because this is 0 matrix, right? So 0 minus anything is going to be this number itself, this matrix itself. So it will be minus A plus 5 into I. This is nothing but 1 by 7 into, I can write it as 5I minus A. Now let's do the substitution. A inverse is 1 by 7 into 5I 1001 minus A. A is 3, 1 minus 1, 2. This is A. Let's simplify this. So it's going to be 5005 minus 3, 1 minus 1, 2. So let's subtract. 5 minus 3 is 2. 0 minus 1 is minus 1. 0 plus 1 is 1. 5 minus 2 is 3. This entire thing into 1 by 7. So you'll get 2 by 7 minus 1 by 7, 1 by 7, 3 by 7. So this is A inverse. Let's go through a topic on singular and non-singular matrices. Very simple topic. A matrix which gives its determinant as 0. If the determinant of any matrix is 0, then it's called as a singular matrix. If the determinant is not equal to 0, then it's called as non-singular matrix. Let's take example. Say matrix A. Matrix A is 3, 6, 2, 4. Now let's find the determinant of this. Determinant would be 3 into 4, 12 minus 12. So 0 is the answer. So therefore this is singular. Let's take an example for non-singular. Say another matrix B. We have 2 minus 3, 4 and 4. Now if you calculate determinant of this matrix, you will get 8 plus 12, which is 20. And this is not equal to 0. Hence this is non-singular. Let's take an example where we have to find X. A matrix is given. This is the matrix. We have to find X, and they have told that matrix is singular. So what is the condition for a singular matrix? Determinant is 0, right? If you take this matrix as matrix A, then determinant should be 0. That is a condition of singular matrix. So now let's calculate the determinant of this matrix. So it will be 2x into 5x, 10x square minus 9 into 4, 36, right? And this will be 0. Determinant is going to be 0. So 10x square minus 36 is 0, which means 10x square is equal to, shift this here, going to be 36, which means x square is equal to 36, shift this here, so it's going to become 10. So you're going to get, therefore x is equal to root of 18 by 5. Put plus or minus. So this is the value of x. There are a few keynotes. A inverse exists. See, every matrix will not have an inverse. It's not necessary that every matrix will have an inverse. So there could be certain matrices where inverse does not exist at all. The way to identify is, if you find the determinant of that particular matrix, if it is not equal to 0, then A inverse, then we can find A inverse. But there are certain matrices where determinant is 0. We just saw that. There are certain matrices where determinant is 0. In such cases, for those matrices, A inverse does not exist. The next one is A into A inverse is A is equal to A inverse into A, and it is equal to identity matrix. Similarly, A into B, the whole inverse, is equal to B inverse into A inverse. Remember this order. B comes first and A comes second. Similarly, fourth property is A into adjoint of A is equal to adjoint of A into A, and this in turn is equal to determinant of A into I. Fifth property is you can adjoint of AB is equal to adjoint of B into adjoint of A. Again, B comes first and A comes second, right? Remember this order.
With this, we've come to the end of this particular topic. Thanks for watching.